We now determine the average velocity over the given time intervals. So let's take this first interval, that is 1 comma 1.5. So we write average velocity. This equals change in position over change in time. So this is the formula that we use to determine the average velocity of an object. So here we are given this position function or the height function. We can utilize this to determine the average velocity for this interval. So therefore, when we compute average velocity for this interval, we write down this average velocity equals, this equals y of 1.5, the height of the object when t equals 1.5, minus the y of 1, the height of the object when t equal to 1, divided by change in time, that is 1.5 minus 1. So the numerator will give the change in position or the change in height, divided by the denominator will give change in time. So let's evaluate this. So we have to plug in 1.5, that is t equals 1.5 into this equation to determine y of 1.5, and plug in t equal to 1 into this equation to determine y of 1. So let's do that. And when we do that, we get 58 times of 1.5 minus of 58, sorry, 0.83 times of 1.5 quantity square. So this is the first part, minus y of 1. Y of 1 is 58 times of 1 minus of 0.83 times of 1 square. This is all over. 1.5 minus 1 is 0.5. So we can calculate this. We plug this into the calculator. We calculate this minus of 0.83 times of 1.5 quantity square. And then this will become negative 58 and this quantity will become positive 0.83. We then plug it everything into the calculator, and when we do that, we get the value as approximately 55.925, and we put the unit of the average velocity as a meter per second. So this is the average velocity over the time interval 1 comma 1.5. In the same way, we calculate for the other time intervals, that is for 1 comma 1.1 and for 1 comma 1.01 and for 1 comma 1.001. We have to use the same formula, that is average velocity equals change in position over change in time, and we plug this value in the calculator and we will get the values of average velocity. So here I have calculated the average velocity for the other remaining time intervals. This is 56.257 meter per second for this second interval, and 56.3317 meter per second for the third interval, and finally 56.33917 meter per second for the fourth and final interval. So this is how we have to calculate the average velocity over the given time intervals. Now let's calculate the part B, that is we have to determine the instantaneous velocity after 1 second. So for that we have to find the derivative of y with respect to time and evaluate at time equals 1 second. So I'm going to copy the function y, that is the height function is given as 58t minus of 0.83 t square. Let me differentiate both sides with respect to time. When I do that, differentiation of y with respect to time is dy over dt, and this is 58 times of differentiation of t is 1 minus of 0.83 times of differentiation of t square. When we use the power rule, we get 2t. So let's simplify this. This gives 58 times of 1 is 58 minus 0.83 times of 2 gives 1.66. We then have t. So basically, this is the instantaneous velocity function. Now we can utilize this to determine the instantaneous velocity after 1 second. So that is, we have to plug in t equal to 1 into this equation. And when we do that, we get dy by dt, that is instantaneous velocity. After 1 second, this equals 58 minus of 1.66 times of 1. And this equals 56.34 meter per second. So this is the instantaneous velocity after 1 second.